Every phone, laptop, and smart speaker in a house is constantly asking the same quiet question. Where is this website? Where is that app server? What address should I actually talk to? That question is DNS, the domain name system. It is the internet's phone book. You type a name, something else, somewhere else, hands back a number. Here is the part that matters. In most homes, nobody in the house is answering. The router or the internet provider or some distant public service answers automatically. Ads ride along, trackers ride along. The household never sees the list of names being asked and never gets a vote on which names are allowed. Imagine a front desk that never shows you the guest book. Every device still walks up. Every request still gets a destination. You just do not see who signed in. The source behind this story is a simple home network recipe. It starts with a picture: the internet, a router, a cluster of devices, and then a local checkpoint sitting on a computer, inside Docker, on a base operating system. The claim is not magic security. The claim is control. Can a household put a visible gate on that invisible phone book? That is the stake. If the answers stay automatic, ads and tracking requests travel with ordinary browsing. If the answers can be intercepted locally, the house can start deciding. So the first question is not how to install software. It is this: what exactly has been getting through? Pi-hole is the local answer the source offers. It is a Linux-based web application, free, open source, meant for homes and small offices. What it actually does is narrower than the word secure might suggest, and that precision matters. Pi-hole sits on DNS. When a device asks, "Where is this name?" Pi-hole can refuse names associated with advertisements and internet tracking. It can manage block lists. Those are lists of domains you do not want answered. And it can show a graphical display of network queries, so the invisible guest book becomes a dashboard. Think of two rival receptionists. The default DNS path is convenient, automatic, and almost never seen. It will happily look up a news site and a tracking pixel with the same cheerful efficiency. Pi-hole is slower to set up, more visible, and more opinionated. It still needs the wider internet for names it does not block. It is not a complete firewall. It does not promise that every ad, every tracker, or every threat will vanish. It is a filter at the phone book layer. Here is a concrete example. A tablet opens a recipe page. The page itself is a name you want. The page also tries to load a handful of other names: ad networks, analytics, maybe a video tracker. Without a local filter, every one of those names gets an address. With Pi-hole in the path, the wanted name can resolve, and the unwanted names can be blocked at the lookup, before the tablet even starts downloading the extra junk. The hook is cruel and simple. Blocking is useless if the house never sends its questions to Pi-hole. A beautiful dashboard on a machine nobody asks is just a museum exhibit. So how do you install a network service like this without turning the host computer into a science experiment? The source's compromise is Docker. Docker is containerization, a way to launch a service, a web server, a DNS server, in a sealed box, instead of scattering files all over the host. Picture the stack from the architecture diagram. At the bottom, a base operating system. On top of that, Docker. Inside Docker, Pi-hole. The internet still meets the router. The devices still sit behind the router. But the filtering brain is now a container, not a permanent tattoo on the machine. Why that matters for a beginner? If you install a DNS blocker directly on the host, you can collide with the operating system's own name lookup. You can leave leftover services. You can make the computer itself unable to reach the internet while you are still configuring the blocker. A container is the opposite personality. It is packaged. It can be started and stopped. It keeps most of its mess inside the box. The first practical move in the source is almost humble. Start Docker with a system command. Then download the Pi-hole image from Docker Hub, the public warehouse of container images, using Docker pull on the Pi-hole/Pi-hole image. At this point, you have a packaged copy of the software. You do not yet have a working household gate. The container is still cargo. It has not been told which doors to open, which time zone to live in, or where to save its lists. And on Ubuntu, there is a more awkward rival waiting in the wings. The operating system already has its own local DNS helper. If you ignore that helper, Pi-hole and the host will fight over the same job. That fight is the next chapter. On Ubuntu, the source says, skip this if you are not using Ubuntu. If you are, stop and disable a service called systemd-resolved. That service is the host's built-in DNS resolver. It likes to occupy the same role Pi-hole wants, answering name lookups on the machine. This is the C classic two receptionists problem. Both want the front desk, both want port 53, the traditional DNS door. If they both sit there, lookups fail in confusing ways. Websites vanish. The container cannot even finish setting itself up. So the recipe is blunt. Stop the service, disable it so it does not sneak back after a reboot, then change the host's own DNS to something else, like Google's public resolver at 8.8.8.8. By editing a file the source writes as /etc/resolve.conf, a small documentary honesty. That file name is reproduced the way the article printed it. On many Linux systems, the usual file is resolve with a V. Follow the article's intent. Give the host a temporary external phone book so it can keep working while you build the local one. Why 8.8.8.8 here? It is a bootstrap. You are not making Google the household filter. You are giving the computer a known gun lookup path so Docker can pull images and Pi-hole can come online. Later, devices will be pointed at Pi-hole instead. The analogy is a construction detour. While you rebuild the front desk, you send staff out a side door. When the new desk is ready, you bring the traffic back through the main entrance. Cargo is downloaded, the rival on Ubuntu is told to sit down, the host can still find the internet. What is still missing is the blueprint that makes the container reachable, the compose file that opens the actual doors. The source's turning point is a YAML file, docords-compose.yml. You open it with a text editor, paste a service definition, and save. This is the moment the idea becomes a machine the network can actually talk to. The file name's a service, Pi-hole. Container name, P-I-H-O-L-E. Image, Pi-hole/Pi-hole. Latest tag. Then the ports, and this is where beginners should slow down. Port 53, TCP and UDP. That is DNS. If this door is closed, no device can ask Pi-hole a name question. Port 67, UDP. That is DHCP, the protocol that can hand devices their network settings, including DNS, if you ever use Pi-hole that way. Ports 80 and 443, HTTP and HTTPS, the web doors to the admin interface. Environment, time zone Asia/Kolkata in the article, a reminder that logs and graphs live in a real clock. Volumes map two folders on the host into the container, one for Pi-hole's own data, one for DNS mask configuration. Those folders are memory. Without them, a rebuild container forgets your lists and settings. DNS inside the compose file lists 127.0.0.1 and 1.1.1.1. Those are upstream hints for the container itself, localhost and Cloudflare's public resolver, so Pi-hole still has somewhere to ask when a name is not blocked. Capabilities add netadmin, extra network privilege the service needs. Restart policy, unless stopped. If the machine reboots, the gate should come back unless you deliberately shut it. Here's the part that matters. This file is not decoration. It is a contract. Which doors open, what persists, who the container asks next, and whether it survives a power cut. The service can now be launched, but launching is not the same as ruling. Devices will still follow their old DNS instructions until someone changes the address they ask. Launch is one line. Sudo docker compose up, then -d. Detached. The container starts in the background, like a night clerk who does not need you standing at the counter. Then the source has you step inside the box. Docker exec, interactive, the container named Pi-hole, a bash shell. From there, one command changes the admin password. Pi-hole-a-p. You set a password a person can remember and a stranger cannot guess. Then you type exit. You are back on the host. Now the program becomes visible. Open a browser to http localhost/admin/, or if you are on another machine, find this computer's address with ifconfig and paste that IP into the browser, then the admin path. The login screen is the first proof that the web doors in the compose file were not theoretical. Type the password you just set. Behind it, the source shows a dashboard, colored summary panels, and graphs of queries over time. Traffic that used to disappear into someone else's phone book is suddenly counted in your kitchen. Do not confuse observation with control. Opening the dashboard is like installing cameras in the lobby. Changing DNS on a device or on the router is what forces every guest to walk through that lobby. A worked example. You start the container, you set the password, you load the admin page on the same machine. You can already see queries from that host if anything is pointed at it. Your phone on Wi-Fi, though, is still asking the router's default DNS. The museum is open. The city is still using the old post office. So the next question is practical and a little political. Do you convert one laptop or the whole house? The source walks a Windows path because that is where many households still flip the switch. Settings, then network and internet. Ethernet if the cable is in, Wi-Fi if the laptop is on wireless. Change adapter options. Right-click the adapter, Properties, select Internet Protocol version 4, IPv4. Properties again. This is the invisible switch, drawn as a boring dialog box. By default, the machine obtains a DNS address automatically. That usually means trust the router and trust whoever the router trusts. The recipe says, stop that. Choose Use the following DNS server addresses. In the preferred box, write the IP of the machine running Pi-hole. In the alternate box, the article says you could write any DNS, like 8.8.8.8. Why a second address? It is a safety net. If Pi-hole is down, Windows may fall back. That is also a leak. Queries that miss the local filter can go straight to a public resolver. Convenience and control tug in opposite directions, even inside one dialog. Worked example 1. Only this laptop. Ads and tracking domains may start failing to resolve on that one machine. Your phone, your TV, your partner's tablet, unchanged. Worked example 2. The same Pi-hole IP entered in the home router as DNS. Now new devices that ask the router, who should I use as a phone book, get pointed at the container. The filter scales from a personal preference to a household rule. The source does not measure how many ads vanish. It does not claim malware immunity. It shows a sequence. Make the service, open the panel, then point DNS at the service. The responsibility arrives with the power. Someone has to keep Docker running, keep lists sensible, and notice if the fallback starts carrying traffic around the gate. Return to the opening image. Devices still ask where names live. They always will. The difference is who is allowed to answer. The resolution is architectural, not mythical. Docker hosts Pi-hole on a base operating system. Pi-hole can block domains tied to advertisements and tracking, manage block lists, and display queries. You start Docker, pull the image, call Ubuntu's built-in resolver if needed, write the compose file, bring the container up, set a password, and open the admin page. Then you point a computer or the router at the Pi-hole IP. Requests that once disappeared into an external default can become visible and governable inside the house. What this knowledge makes possible is modest and real. A small office or a family can put a checkpoint on the phone book. They can see the shape of their own lookups. They can refuse some of the names that used to ride along for free. What it does not make possible is forgetting the trade. A dashboard is not a guarantee. A block list is a policy, and policies have false positives. A site that breaks because a needed name was on a list. A fallback DNS is a fire exit that can also be a side door. A container that is not running is just a dark room. The field is still chasing a larger question, and it is the right place to leave you. As networks become more consequential, more cameras, more speakers, more things that phone home, should the invisible services that decide where devices may go stay automatic? Or should ordinary people be able to inspect them, argue with them, and sometimes say no? The guest book is optional. The questions are not. Who answers in your house is now a choice.